Okay, hello everyone, I'm Shogun. Next, we'll handle the call method we had earlier. We haven't written this method yet, so let's complete it now. This method mainly converts the data we received into WAV data, which needs to be written locally. So we must use async. If you don't use async, there will be problems. Let's first copy the two delegates of the web file here. Then we prepare the data. We'll copy a copy of the data right here. Copy it out. After copying is done, then we dispatch an async task like this. This is the classic writing style for polling. Inside this async task, we need to do a lot of work. So we prepare a WAV data. Okay, we'll convert it here. There shouldn't be any issues with this part. You don't need to use this here. Okay. Let's write this method as static. Write it as static. Yes, it's fine as static because this is a static method. Okay, we can write it like this. Because the AB here might encounter a situation where this object gets garbage collected. So we copy everything out because our actual garbage collection depends on this. We receive the message to synthesize the audio object and this EB read write. We should not let it affect the life cycle of our entire object. So this method uses a static approach. Then we directly store it locally. Check if it was successfully retrieved. But it might fail because the path might be written incorrectly or something. Then on our side, we prepare the delegate we want to call, right? Then we prepare a message on our side. If we successfully store or retrieve it, then we take this message. We consider this agent as successfully call and store this agent. If it fails, we call the failure agent, then update the information. Here we send another task to the main thread. This way the main thread will know whether this item has been successfully stored locally. So that's how it is. So this is equivalent to us performing an asynchronous audio conversion. I/O read and write. You might say the conversion here, or the conversion you just did with this message. The conversion here, there will be a little bit of repetition. Actually, it is not repeated because your function, this onMessage function, it will affect the entire life cycle. And this thing, it means that this, that is to say, this, use some more under runtime. It does not execute, therefore, in this place, although it looks like repetition. But actually, the real execution happens after packaging. This piece of code actually does not exist at all. So this is a situation. Okay, now let's test it. Let's see if we can succeed. Call USoundWave, save this file locally. Then play it from our local machine. I'll start this project on my end. Okay, this pin on our side should also be able to trigger successfully. Let's pull this pin out. After pulling it out, we set the options here. Then we need to build a path here. Right. As for this path, everyone should be familiar with it. So how do we construct it? Project should be saved. We get the project shape path. Then we open a file called test.wav. Okay, after getting this path, we convert it to an absolute path. Convert it to an absolute path. Okay, we put this path here. Put it here. Okay, once that's done, no problem. Let's just do it like this. Let's print this log. Let's take a look. Okay, now let's execute it again. Okay, you can see that we have finished outputting it here. So let's go check whether this file was also successfully generated. Generated in this way. It should be here, here, and this is the SERM one. There should be a TESWAV. Now I'll turn off the microphone. Let's play this audio. Study hard. Okay, let's have it resynthesize once, because I feel that the data from the synthesis seems to have some issues. Let's have it synthesize again. Study hard. This problem is not caused by my side. It's on the Thunder player side. There's a bit of an issue here. Let's switch to a different way of opening it. Let's play it again for everyone. Study hard and make progress every day. Study hard every day. Study hard and make progress every day. Okay, so here we give it an out and betterize. Give it okay. Okay, actually, this boolean should be fine. You'll know whether it loaded successfully. Then how do we handle this part? It's actually quite simple. So here we need to use this. We must configure something like this to process it. I'll just copy it directly. First, by default, it definitely fails to load. Then here, we pass this path into it. We check whether this path exists. Then we directly call this method. If this thing exists, we will load it. Just do more checks like this. Then here we directly convert it to binary to get it. Let's see if this method can be used successfully. Let's start it first. If you want to do streaming, how do you do it? You just do the streaming within this message. Because you mentioned designing a full streaming interaction. We actually have a video that explains it. It covers how to design this full streaming voice interaction system. We'll show you this video in a moment. And here. Then we should have here. We did not expose it to Blueprint. I will expose it to Blueprint here. Forgot about the person. Then let's keep it simple here. We'll move this silver watch over. Then we'll make it purable. In the world context here, we won't need it. This thing is not needed either. As for this display lim, let's just call it Junfei load fail. Okay, we won't need the keywords either. For the category, let's put it here. Okay, now let's restart it. Check this place. Is there something written wrong? It should be that this metadata is missing a bracket. Okay, let's restart it again. Okay, now it has started up. We should have a function interface called loadFail. Then here, we take this path. Remember, this kind of green node for the path. It is often called multiple times. We explained earlier. This green node has a pitfall, that it will be called multiple time. So everyone must keep this expectation in mind. Then here we will print this thing. Let's see if it actually printed the number of this number. Let's see if they successfully loaded this data. Let's test it here. You can see it has been successfully loaded. It's about 64 megabytes. Probably. It should be. Okay. Alright, then the task for this lesson is complete. Because we have successfully generated the WA file. If you want to do mouth-driven animation, you can directly use this WA file to drive it. This is completely fine. Then let's expand on it. Actually, we have a set of videos here, but I have a set of tutorials here. We explained this in detail to everyone. I'll turn off the audio here. Explain this in detail to everyone. How to design a fully streaming, compatible with all large models, fully streaming intelligent voice interaction system. So now I've already explained this to you. TTS explained ISTT and also explained this to you. The Winqing Yin large model. So we'll assign him a slightly lazier commercial assignment. You can all give it a try. Based on what I've told you about this, you should make such a distinction, but you might not be able to finish it. Because you may still not have digital assets yet, and you don't have a lip sync driver plugin either, but because you are aware of your current capabilities, you should be able to handle this kind of full pipeline interaction. Okay, well, this is quite complex. I think it can't be covered in just 1 or 2 sessions, or even 2 or 3 sessions. Maybe to respond aggressively chapters. So the content of this chapter is basically about enough. Okay, in the next 1 or 2 sessions, we will expand a bit on other engines. They have some bit methods at the underlying level, done some interfaces to handle SoundWave. But unfortunately, there is still no way to bypass this issue caused by the update to version 5.4.3.